Hi everyone, we now work through this exam-style question involving composite triangles that are hidden inside a quadrilateral. And knowing how to solve this question is a must-know because it involves the cosine rule, the sine rule, as well as the formula involving sine for calculating the area of a triangle. So let's see, we're given this quadrilateral, ABCD, and the first thing we need to find, question 1, is the side length AC. That's the side length we see right here. Now for that, I'll just write SOL here, as in solution, and I'll write a little 1 to indicate that we're answering the first question. When solving problems like these, in which two or more triangles are made up to make another shape, I like to draw the triangles separately. In particular, for side length AC, I'm going to be using this triangle ABC. So if I make a quick sketch here, that's the triangle here, there we go, and that's triangle ABC. Next, I add all the information I can to this triangle from the original diagram. So side length AB is 74 meters, side length BC is 63 meters, and the angle at B is 73 degrees. Looking at this triangle and the side length AC that we need to find, we can see that we have its opposite angle as well as the other two side lengths. And as soon as that happens, we use the cosine rule. And I'll use the right-hand side here to remind us of what the cosine rule states. So I'll just draw a generic triangle here, like so, which has side lengths lowercase a, lowercase b, and lowercase c, and interior angles capital A, capital B, and capital C. Now, let's say for a second that the unknown side length we're looking for is this side length c. Then the cosine rule states that c squared equals to a squared plus b squared minus 2 times a times b times cosine of the angle capital C. And in fact, I'll go ahead and box that. That's the cosine rule for finding an unknown side length. Notice that what this rule is telling us is that to find the unknown side length C, which is here on our triangle, all we need are the other two side lengths A and B, as well as the angle in between them. That's the angle capital C. So going back to the triangle we have here, and renaming the side length AC x, we can state that x squared equals to the sum of the squares of the other two side lengths, so that's 74 squared plus 63 squared, minus 2 times the product of the other two side lengths, so that's 74 times 63, and that multiplies the cosine of the angle between them, so that's cosine of 73. Now, if I calculate this, I'll get the value of x squared. So to find x directly, I take the square root of all that. So I write a long square root here, like so. So x equals to the square root of 74 squared plus 63 squared minus 2 times 74 times 63 times cosine of 73. And by all means check, but if I plug all of that in my calculator and round to 3 significant figures, I find that x is equal to 82.0 meters. And that's the first question done. And in fact, I can label that on my diagram here. I'll say AC is equal to 82 meters. Okay, I move on to question 2. Now in question 2, we need to calculate the angle CAD. Looking at the diagram we're given, the angle CAD would be this angle right here. Now, as will often be the case in this type of question, we're now going to focus on the second triangle we have here. That's the triangle ACD. And in fact, I'll start by making a quick copy of it, something like this. Okay, so that's my triangle A, C, and D. And if I add all the side lengths and angles we have 82 here, that's 82 meters, and we have 61 meters here, and we have this interior angle, which is 59 degrees. And we need to find this interior angle at A. Well, looking at this triangle, we notice that we already have one side length and its opposite angle, that's 82 and 59 degrees, and we have the side length opposite the angle we're trying to find. And as soon as we have this type of scenario, we use the sine rule. And again, I'll use the right-hand side here to remind you of the formula. Still referring to the triangle we have here, the sine rule for an unknown angle states that sine of capital A over side length A equals to sine of capital B over side length B, and that's equal to sine of the interior angle capital C over the side length C. And again, I'll go ahead and box that. There we go. At times, the sine rule can be a bit confusing, and perhaps that's because there are two equal signs and three terms in this formula. But what's important to realize here is that we only ever use two terms at a time. And in fact, I prefer to think of the sine rule as sine of any interior angle capital X divided by its opposite side length has to be equal to sine of any other interior angle capital Y divided by its opposite side length, Y. With this in mind, I can go back to the angle A here and state that sine of A over 61 has to equal to sine of 59 over 82. And I'll go ahead and write that. That's sine of the angle at A over 61, its opposite side length, equals to sine of the angle 59 over its opposite side length, 82. Rearranging this, and I'll do this up here, I can state that sine of A equals to 61 times sine of 59 over 82. Finally, to find the angle A, we use the inverse sine or arc sine and state that A is equal to the inverse sine of 61 times sine of 59 over 82. And by all means check, but with my calculator and rounding to one decimal place, I find that the interior angle at A is equal to 39.6 degrees. And that's the second question answered. And so we move on to the third and final question. We need to calculate the area of the quadrilateral ABCD. In other words, we need to calculate the total area we see here. And the approach here is to calculate the area of triangle ABC and add that to the area of triangle ACD. And to do that, we're going to need the formula for the area of a triangle involving sine. And I'll write that formula up here. Given a triangle like the one we have here, to calculate its area, all we need are two side lengths and the angle between them. So for instance, the side lengths A and B and the angle C between them. Provided we have that, we can state that the area is equal to 1/2 times A times B times sine of the angle between them. So that's capital C. And I'll go ahead and box that. There we go. Now back to our problem here. The area of the quadrilateral ABCD equals to the area of the triangle ABC plus the area of the triangle ACD. Now to save a bit on space here, I'll go ahead and do the working down here. For the triangle ABC, I'll write it here. Area ABC equals to, so it's 1/2 times the product of two side lengths, like 74 and 63, times the sine of the angle between them. So we'll take the sine of the angle 73. So that's 1/2 times 74 times 63 times sine of 73. And I can already write that here. That's equal to 1/2 times 74 times 63 times sine of 73. So that's the area of triangle ABC. And I need to add to that the area of the triangle ACD. Now, looking at triangle ACD, we can see that we definitely have two side lengths. Those are 82 and 61, but we don't have the angle between them. What we do have, though, are the other two interior angles. Indeed, we have 59, and in question 2, we had calculated this angle here at A. That was 39.6. And I'll add that to the diagram. That's 39.6. So using the fact that the interior angles have to add up to 180 degrees, we can quickly figure out that the interior angle at C is equal to 180 minus 59 minus 39.6. And by all means check, but I find that that angle C is equal to 81.4 degrees. And I'll add that to my diagram. That's 81.4 degrees. Now that that's done, I can use the area of a triangle formula and state that the area of triangle ACD equals to 1/2 times 82 times 61 times the sine of the angle between them, 81.4. And I'll go ahead and write that here. That's 1/2 times 82 times 61 times sine of 81.4. And by all means check, but with a calculator and rounding to one decimal place, I find that that's equal to 4,702.0 square meters. And that's the answer. And there we go. That's it for this exam-style question involving composite triangles and the cosine rule, the sine rule, and the area for a triangle formula. And that's it for this tutorial.